Thank you. Old weather has got to be the most engaging project I've ever had the luck to work on.
Can I turn down the light for a moment?
Yeah. Not just because what we expect to yield in terms of new science data, but because of the group of collaborators I'm working with. Philip Broen at the Hadley Center in the UK and 20,000 other collaborator citizen scientists who I actually engage with every day. Well, not all of them at once, but it is just an amazing opportunity to be able to sort of meet people through old weather and talk about things that we care about, having to do with old data or climate or what things were like back in the day on a sailing ship, which I know a little bit about. But the main purpose, of course, is data rescue. And I have to figure out where the button is on this. Whoop.
Sound right.
There. There. Ah, that was the wrong one.
Sorry.
Here?
It's this one?
And it didn't work. Bing.
I guess this way.
Bing. Okay, thank you. There's always a technical thing. So why data rescue? The changing Arctic is a harbinger of global future, but to understand emerging patterns, we need to know more about the past history of the Earth's weather. Our currently available data sets are not sufficient to the task at hand. They're usually too short. For instance, sea ice, what you generally see about sea ice in the Arctic starts during the satellite era in 1979, give or take. Pretty short stuff. It's spatially incomplete, or the temporal resolution is too low. But luckily, far more data exists, especially in the area of marine meteorology, that have been utilized so far, on the order of gazillions of observations. That's a number I think Gerard will appreciate. The problem is they are in inaccessible formats. But new technologies are transforming the way we recover and use large amounts of historical weather and environmental data. And this is the real Wayback Machine, crowdsourcing coupled to reanalysis. This gives us unprecedented ability to squeeze new information out of this old data. So where does it start? Back in 1853, Lieutenant Maury organized the Brussels Conference, and that is where they decided to standardize the collection of marine met data among all the ships of the world's different fleets. The reason that he was interested in that was so they could construct pilot charts of the world oceans. You see an example here from 1892, I think it is, but it's sort of the first systematic assessment of the weather and sea conditions over the oceans for the benefit of navigation primarily. Then in 1923, the International Meteorological Conference organized the first data rescue project. And that effort became the World Weather Records published by the Smithsonian in 1927. These two different efforts basically form the foundation of the basic climate data sets that we still use today, including all these acronyms here. One of which ICOADS will be focusing on today. It's the International Comprehensive Ocean Atmosphere Data Set. This is the foundational data set for any gridded data set that uses marine observations of the surface ocean. Then you can see, even right away, back in 1913, we started to see what the large-scale patterns of atmospheric circulation look like. Exner, 1913, of course, Walker described the NAO in the 1930s. And then we have the AO more recently. I think somebody around here had something to do with that. So that's the kind of thing you can get out of rescue data, even back in the day. Now there are new needs and new demands on the kind of data we go after. And what you could see right away is the question nowadays, what's the context? Has whatever this fill in the blank happened before? Is this superstorm unusual or is it not unusual? In the Beaufort Sea, we're working on this interesting diversion of the last few years where we're starting to see the ice melt way back and then a very strong inclusion of fresh water from the Mackenzie Delta, making it way out over Barrow and creating this very warm anomaly in Beaufort Sea, which tends to last into October, which you can see here in the bottom panel. The temperature, both at Barrow and of the over ocean air temperature, going up since about 2004 or 5, quite dramatically, to the point where folks around my office are talking about, well, is there a new normal emerging in the Beaufort Sea? Of course, the first thing someone does, they raise their hand and say, well, how do you know the ice didn't go back in the 1930s? You know, we've heard that there was an Arctic warming period kind of thing in the 1930s, and well, how do we know this is so unusual? Well, actually, there are observations. If you go look for them, you can find them. And this is an example from 1933, which is typical of everything I've seen anyway, of the era, where none of the maps, based on physical observations, show anything like the kind of meltback we're seeing lately. And that's the kind of story we're looking to be able to tell more generally. So then, how have things progressed? So when World Weather Records came out, we were dealing basically with simple statistics. You compile the data, you do some work with it, and you can come up with means and things like that. And then, in the 50s, we started to move into gridded data, which you could do more sophisticated statistics on. But now we're into the era of the reanalysis or retrospective analysis, where we can really reconstruct the state of the atmosphere at high resolution based on just surface observations. However, now we need sub-daily resolution data. So a lot of the stuff that was compiled before isn't sufficient for this task. So we have to go back and look again at what data has made it into ICOADs and increase the resolution, and also go after more and more of the older data, because now we have a real way to use it. And among those variables that we are collecting, the highest priorities are pressure, sea surface temperature, and sea ice, because those are the only variables that sparse input reanalysis needs to run. So we're focusing right now on that. So what does an extended reanalysis look like? This is an animation of the winter of 1947 from the 20th century reanalysis. And I'll go out here. The interesting thing about 1947 was it was extremely cold in Europe. And Philip at the Met office wanted to try and understand why that occurred. So this is all historical data that's been assimilated into the reanalysis. And you can see right away that this persistent high pressure over Europe is what's keeping the storms from the Atlantic, which normally bring warm air over Europe. It's diverting them either north or south of that high pressure area. So that's an example of a way you can use a reanalysis to understand a historical weather event. The other thing that is obvious when you see this is that most of the data is in the northern hemisphere. You see the southern hemisphere has what Philip calls the clouds of ignorance floating, where there's not quite enough data to drive the reanalysis. Of course, there's some discussion about whether there's too much fog, or where exactly that fog should be to be representative, but it's still, we know there's not enough data, and so that's one area we should be focusing on in addition to the Arctic. Would be the southern hemisphere.
Sorry, are the dots?
Yeah.
The dots are where you have data, I assume.
The dots are stations if they're not moving, and they're ships if they're in the ocean, they're moving. And they're also colored based on the pressure observations they were seeing at the time. And so what you're seeing there is the pressure field, sea level pressure field, and the 10-meter winds displayed.
I'm sort of curious about what seems to be relative absence of data in Western Europe as opposed to Russia. Is that by choice, or?
1947 was right after the Second World War, and that may have something to do with it. I don't know how long it took them to get their network back up again, but what's that?
India was doing well.
Yeah, yeah. But I don't have an immediate explanation. So 2 tabs works. This is my first try at doing animations in a talk, so okay. So that's what it looks like. I wanted to show that for folks that haven't seen one of those before, but that's the end product that we're aiming for with all this effort to get the historical data back. So where is the data? This is our current area of focus in the Pacific Arctic area, and you see that in ICOADS there's virtually nothing in the Bering Sea and in the Arctic. Each of the dots you see there is an individual ship report at a particular time, so if there was any report at all, it would show up. But there's nothing in ICOADS, yet we know many ships were collecting hourly observations in this whole region during this period. Ships like this, so the revenue cutter Bear, you may have heard of, USS Jeanette, more or less famous ships if you're interested in the history of Arctic exploration. But then there's lots and lots of other ships like the USS Penta here that were just workaday ships that were working up there day in and day out collecting hourly observations pretty much without fail. They collected data that looks like this. This is a typical Navy logbook of the era, and you see hourly observations of the main meteorological variables on the left-hand page, and then a very detailed description of the ship's activities every day. The right-hand page has just routine things like what sails were up, but also sea ice observations, whether anything interesting happened, if they saw wildlife or whatever, often that's recorded. You never actually know what you're going to find on that page. This is the central question, though. How do you get all those scribbles turned into data? Because it's not machine readable. And the scale is just enormous. There are millions upon millions upon millions of observations that are out there that are unavailable because of the issue that it is unmachine readable handwriting. Well, the answer is old weather and citizen scientists. This is the front page. It's basically a guided interface that takes people through the logbooks and helps them transcribe the variables in the right spot. But it has been astoundingly successful. There's a great cadre of people working on it, and we are already passing, a couple of days ago, 20-something thousand pages since the launch of Old Weather 3, or Old Weather Arctic, which we're talking about here, last October, early November. So they're crunching through the material we're putting up pretty quickly. So what's the process like end to end? We have a team working at the National Archives to actually produce the photographs of the logbooks, which is the first step. You can see our imaging station here with Elizabeth there. We have 2 of these imaging stations set up at the archives under the direct supervision of Mark Milan, who's the Navy Maritime Archivist there. They've produced so far approaching 280,000 pages of logbook data that are in the process of being loaded onto Old Weather. You get to Old Weather, you do the crowdsourcing, some QC, then it goes on and we'll integrate it into ICOADS as ship reports, at which point every time there's a new version of a reanalysis, either the 20th century reanalysis or Ericlem or whoever's picking up ICOADS for their research, the data will be available then for assimilation. So it's a pretty cool arrangement. So it is very highly efficient. This shows a proportional. Each square is proportional to every person's effort. If you've transcribed a page or more for the first 2 phases of Old Weather, you're in this map. And what you see, there are 16,400 squares who transcribed one of at least 1,090,745 pages over the first 2 years of the project. You can see that another interesting thing is that the way the squares are distributed, we kind of like to think that a lot of people are doing a lot of work, and they are. I mean, there's a lot of contributions down in this corner, but there are also some people I would refer to as the dreadnought class that they just transcribe massive amounts, and that is something that makes them happy. And that's great. And I would wager most of these people on this end are the ones you find on the forum who know everything about the ships and the names of the people and and are really, really into the project. So this is a very nice animation that shows the output of that first 2 phases of old weather. So they were concentrated on the World War I era Royal Navy. Royal Navy logbooks. And what this shows is what that looks like sort of spatially over the course of the war. So what you're seeing these are all new observations, new to science, added because of old weather. And we've captured something on the order of 75 to 80% of the movements of the Royal Navy during the First World War era. So there's just a tremendous amount of information picked up in the first 2 phases. I like watching this ship zipping all over the place. And when you think about it, that's somebody at home sitting typing data into their computer from a handwritten logbook. I should get the date up so you can see yeah, there we go, 1918. So then destroyers start escorting, and you see a lot more traffic on the Atlantic. And anyway, so we'll be producing something like that with the current version of old weather, except it will be spread out over a lot more time and tend to be focused on the Arctic. Although our ships, because of our agreement with the National Archives, we're doing the whole ship's history. So if a ship went to the Arctic and was there for a year, but was in service for 45 years, we're going to see data from basically from all over the world. Okay. So what does it look like when this data starts flowing out of the logbooks? We make these videos here as part of the QC process, but again, it is amazing to watch how much information is flowing from the volunteers. Let me see if I can move this forward. So the first few pages cover all of the engineering stores and everything they loaded on the ship. And so we just got, so the ship's trapped in the ice already, but it's up in the Arctic. And you can just see all the weather information just every day flowing out of the logbook into a form that's now usable. It's assimilatable data. The other thing that this shows very clearly is that we're moving from an item level manuscript kind of metadata where people know their logbooks and there's something in them, to a state where we now know where most every word in that manuscript is located. So we can now search on manuscripts using word, keyword, anything like that. So it's going to massively increase the accessibility of the information that's in the logbooks, because now you can search for it online, anywhere in the world. And now we have sea ice too. This is the first round of sea ice observations that we pulled out during the beta test phase. It's from the Thetis in 1884. And the point of the graphic that Philip produced is just to show that we're getting observations where you're supposed to in the ice, and that they're good information. And incidentally, for this, this was part of the Greeley Relief Expedition in 1884, so we also have photographs that we can locate in time and relate them to the logbook. So we can actually see the ice that they're talking about in a few cases with these photographs, which is, I think, pretty neat. And there's a lot of direct ops applications you can think of if you consider the ships that we're dealing with. Many of them got stuck in the ice, or several anyway, and therefore they're really the first generation of instrumented drifters that we have to work with, because they collected all this weather data, sea ice thickness, their position. So the Jeanette drifted off into the Chukchi and the East Siberian Sea over the course of a couple years. So now we'll be able to compare that drift to what buoys are showing us nowadays. We're also going to add between 60 and 130 years of new sea ice reconnaissance information, which can be used in a variety of ways. So then on the practical side, we we built Old Weather, or Philip built Old Weather, and then we moved into Old Weather Arctic, and then you have to ask the question, well, how will you get people to show up? So the idea is that you have to make as big a splash as you can, get out there in the media, because without some kind of coverage, it's hard for people to find out what you're up to and whether they want to come and try it out. So, so with the help of NOAA Public Relations and National Archives Public Relations, we put together a press conference at the archives last October, and it made a pretty big splash. You could see we got out into the world media a little bit, and the idea then is to pick up participation. And in fact, every time we do one of these things, the tracking on the website definitely jumps up quite a lot, actually. And then there's a tail, but then we pick up enough people doing work that it makes it worthwhile. So why do people come to Old Weather and stay? One of our colleagues at University College London did a survey not long ago, and what she found, was that really what's motivating people when they answer the survey is they have a general interest in science, and they also have a strong desire to contribute, to help out with science somehow. And then they have an interest in history, and meteorology is really down somewhere. It's not, I mean, it shows up on the radar, but it isn't the biggest motivator out there. What we're realizing, though, is that the forum is an important part of Old Weather, because that's where everyone who participates has a chance to come together and talk with each other. So there's a bit of a community forum there. There's also a creative space because they put what they want on the forum. It's not regulated, and it stays there. And it gives them an opportunity to use their expertise that they're developing. So with our moderators and sort of experienced people out there watching the forum, if you put a question up, it'll have an answer to it really within an hour. And it doesn't matter what the question is, well, as long as it's related. An example is, there's a device called a cherub. And even I didn't know what it was. And so when I first started going on the forum and getting folks aiming toward the Arctic and all that, I heard all this discussion about a cherub and how it's crucial for the dead reckoning navigation of a British ship. And I'm like, I've never heard of that. I've been a mariner for 25 years. And what is this? It turns out it's the brand name of a patent log. And so the folks on the forum have now developed enough expertise that it's at brand name level knowledge about some of the equipment they're using. And this includes the meteorological equipment too. So they know the difference between an aneroid and a mercury barometer and all that, what that means. So just fabulous. Then, so there's this ever increasing depth of involvement through the forum. But then really, it's the right-hand page. It's the comments. It's the extraordinary stories they find on the right-hand page. Now this is a collection of things that I just picked out as I was processing images over the course of a couple of days, and you just see it time and again, these great adventures, these great events, what's going on. So it's a really big draw for people to, as one volunteer told me, they do the Met and kind of like it's their broccoli, because that's the project. We need the science data, and they're into that. Great, they do the weather. But what they want is their dessert, which is the other page. And so they're into the history and they're into the stories, and you'll see in a minute they've vastly expanded the scope of the project just of their own, because of their own interest. And so what do they see? Things like this, moments of discovery. We're transcribing data, but then on the page it's like, well, here's the Jeanette, and everybody knows the Jeanette was crushed and ended in a terrible tragedy, but beyond that, there are all these daily events that they're tracking and watching out for. So discovery of a new island, that's pretty cool. And so, that's a big motivator. Then the other interesting thing that we've talked about is, how is it we actually have these logbooks? Those of us that have had the opportunity to go to the National Archives and actually put our hands on them, it's really astounding, because they're not small books. I mean, these are giant books. not like logbooks today. And the men of the Jeanette, other expeditions that were stuck in the ice, always made sure the logbooks came home somehow. And so what I'm showing you here is there's this sort of artist's impression of the Jeanette getting crushed, but it was far away from land when it got crushed. It took them several months of dragging boats over the ice. Completely put Shackle in the shade, by the way. He had it easy. So they drug their boats, and then they sailed over to the Lena Delta. One boat was lost. One boat made it ashore, and then which was Melville's party, which is why we have the logbooks today. DeLong's group in a third boat had to carry all their stuff, plus the logbooks, which I'm saying is in that box right there, through a mile of broken ice, because they couldn't make it all the way to the beach with the boats. They had to carry all this stuff on their back to the shore, and they cached it, and then they died. So then Melville comes around later and finds them and finds the cache of logbooks, but the story is not over yet. So he has to then carry them the rest of the way from the Lena Delta back to civilization, which turns out not to be that easy. So he sent two of his deputies ahead with the logbooks, but then they were caught in the seasonal flood in the spring in the valley of the Alden. And as you see, they had a bit of a time keeping the records safe, which the story is just amazing. I mean, they had to climb a tree and lash them up in a tree, meanwhile eating their dead horses. But they did, and so now here we have those logbooks in the National Archives, thanks to them. And then more stuff turns up. The other thing that happened when we launched Old Weather is that everybody, a lot of people popped up with A, different science questions they'd like to answer, and B, the U.S. Navy Bureau of Medicine realized they had a Jeanette logbook, and so they brought it over and we photographed it at the archives, which now fulfills a preservation purpose too, because it's that logbook in particular is pretty fragile, but now we can begin to reunite all of the documents that are related to each other, either virtually or definitely virtually, so that we'll be able to see and sort of recompile all this information. So then, as I was saying before, the volunteers really add a lot of value to the project. They produce their own research, handwriting help, technical terms, all that. None of this could really be done, I think, in a top-down kind of way. It's something that people volunteer to do, and it's driven by their own interests, and it seems to be working out great for Old Weather. So we're getting, in addition to the weather, we're getting all the natural phenomena, crew lists, burials at sea, discipline, desertion, ships met, notable events, you name it. We have a page for it. And then we're, as I was saying before, we get much better metadata on the logbooks in the process. And then there's all the other uses that we didn't imagine when we started, like old space weather. It turns out that people on ships really like to write stuff down they see in the night because it's dark and so they see an aurora, they log it. And so it looks like in collaboration with Solar Stormwatch, we're going to be able to sort of branch off into plasma physics, which it's a whole new field for me. But it looks like it's going to be a good way to sort of map out the effect of coronal mass ejections way back into the 19th century. So who knew? So then the Old Weather Project is really the biggest part of what we're calling the Arctic Rediscovery Project, which is sort of a catch-all fundraising arm, place to put all the photographs and other information we find, general resource, and a way to do student projects and things like that. So there's a website there where you can find out more about the student projects in Old Weather. And this is one of the things that's there, is this photograph and moving picture collection, which is cool, it's just cool by itself. But it also allows our volunteers to connect with the people that they're writing about, which turns out to be another important part of the crowdsourcing aspect, where they can actually see a picture of the crew and the people that they're working with. And getting a lot of these pictures was a project that was done by a high school student, Hallie Ports. we found a lot of these photographs at the Coast Guard Museum Northwest in a big filing cabinet. And she went down and scanned 200 or 300 of them, which are now part of the Old Weather Arctic Rediscovery project. We're also doing miscellaneous sea ice data rescue. This is a collection of Danish Meteorological Institute sea ice maps that were published back in the 30s, which we scanned and have now been published by the NSIDC. So you can go look at all these maps from back in the day if you have an interest in where the ice edge was around Barrow back then. We've done a bunch of student projects. Here are two examples. One demonstrating the different ways you can use historical ice data. So Vivian was a JISAO undergraduate intern who began constructing a historical sea ice index of the sea ice around the Chukchi East Cape area, which we can extend back to about 1850. And that turns out to be a pretty good proxy for the Siberian coastal current as well. Interesting. And we have a high school project going where they have built a replica of a 19th century style thermometer screen, which we put a new platinum resistance thermometer in and sent it up to the Barrow Observatory. So we're getting parallel data between the standard 2-meter instrument there and this antique replica with the thermometer in it. And so they're working out what the bias looks like. Turns out to be not a game changer, really. I was kind of expecting it to just blow it out, but it actually is within a degree all the time. So it doesn't disqualify the data that was collected back then because it wasn't in a standard screen. And if anybody has an idea, you're welcome to come and talk to me and maybe put together a student project, or do a student project of your own. National Archives is also promoting old weather as part of their digitization and transcription scheme. So they've just launched this website not long ago that supports old weather as well. So just to summarize, what do we expect? Obviously a big infusion of new climate data, new old climate data, weather, ocean, sea ice, ecosystem information. This is used to fuel extended reanalysis projects, leading to better environmental prediction. But an important byproduct is this massively enhanced access to documents of national significance. So these are, what we're working with are one-of-a-kind documents that have been in the archives for generations, which are going to be transformed to, got to go there and wait in line to see it, to you can see it anywhere, anytime. And you can search on the documents as well. So currently we have 5 activities using old weather data. There are 4 reanalysis projects, and Hadley ISST, that'll be the next version, are using the data we're generating to both add data and to quality control what they have already. And then since the UK side was a little bit ahead of us, there are 3 museum exhibits that are basically keying off of old weather here. So another interesting side effect of or a side product of the project. So then here we are 129 years after the Jeanette sank. And this is a comment from George Melville, who is the chief engineer. So what is the value of all the work that they did? And he realized then it would take years of patient toil to compile and compute, compare, and apply all this information they collected. I think he had no idea how long it would take. But that's the job old weather is doing now. Thanks.